This next chapter we're going to start is where we're going to introduce proofs. Proof is a logical argument that you're going to make. So anytime in life where you need to prove what you're saying is true, you're using a logical argument to do that. Hopefully you're using a logical argument. If not, then it's not a very valid argument. So what proofs do are they're gonna train your brain to think logically and support your statements with factual information. So if you're writing a research paper in English, that's a form of a proof. You take your position and then you support it with factual information. We teach this in geometry because the facts that we have in geometry you can't argue with. They're facts. They're not opinions. In other classes, when you're supporting your case, most of the time you're going to be doing that with your take on information that you've received. So it's not going to be stone cold facts. So we teach you this in geometry just for that reason. And so it's going to seem like kind of an odd process, but it's a training exercise for your brain to draw upon knowledge you have to support your argument. And in order to do that, we're going to be using these conditional statements. Conditional statements are always in the if-then form, so we're going to analyze what the if part is and what the then part is, and then we'll talk about them more. So I'm going to start with some if-then statements that aren't mathematically based. They're just kind of regular sentences that we're going to use just so you can kind of get the forms down and see what you're allowed to do with these if-then statements. So each conditional statement consists of a hypothesis, which is the if part, and then a conclusion, which is the then part. They're not always going to necessarily have the terms if-then in there, but we can always change a statement to have it be an if-then statement. The if, the hypothesis, is kind of like you're given information. It's what you're assuming is true, and the conclusion is what you're trying to show is true. So when we get to proofs, the if is what you're going to be starting with, and you're going to be working towards showing that the then part is true, and we'll get more into that when we start doing proofs. So here's a statement I have. All mammals breathe oxygen. I'm going to rewrite it so that it's an if-then statement. So I have to look at this and say, well, what's the if part? What has to be true in order for something else to be true? Well, let's see. All mammals breathe oxygen. So if I know something is a mammal, then it breathes oxygen. So that's how I can rewrite this into an if-then statement. So if an animal is a mammal, then it breathes oxygen. This is my if-then form of my original statement. This is a conditional statement now. So how would we prove that this is false? I'm assuming that if an animal is a mammal, then it's going to breathe oxygen. So if I wanted to prove that that was false, I would need to think of an animal that is a mammal that does not breathe oxygen, because that would make this statement false, because this is saying that any animal that's a mammal is going to breathe oxygen. So if I can find one example of an animal that's a mammal that does not breathe oxygen, then that would be what's called a counterexample to this statement. I only need one of those. I need one counterexample Okay, and a definition of a counterexample is an example of something that meets the hypothesis but does not meet the conclusion. Here's another example. Let's have this if-then statement. If a number is odd, then it is divisible by 3. So take a moment and try to think of a counterexample to this. So try to think of a number that is odd, but is not divisible by 3. There's lots of examples you could have thought of. 1. 1 is odd. It's not divisible by 3. I can divide it by 3, but the word divisible means it goes in evenly too. So 3 has to go evenly into it. So 1 will be a counterexample. 7 will be a counterexample because 7 is not divisible by 3. 11. 5. Okay, there's lots of counterexamples. I only need one of these, though. This one counterexample proves this statement false. It's a lot easier than finding all the odd numbers that are divisible by 3. Okay, because to prove this true, I would have to show it's true for every single odd number. But to prove it false, I need just one example where it's not true. So next thing we're going to do with these conditional statements is we're going to get 3 other forms of statements. Okay, so here they are. We take the converse, which is when you switch your hypothesis and conclusion to get a new if-then statement. So all these statements are always going to start if. There's going to be a then in the middle. But we're just switching the way we say what we started with. So I'm going to use my original example. Okay, if an animal is a mammal, then it breathes oxygen. The converse is going to switch those around. So if an animal breathes oxygen, okay, now that part comes first. Then it is a mammal. Okay, and is this statement going to be true or false? Can you think of a counterexample? I can think of an animal that breathes oxygen that would not be a mammal. There's lots of them, right? Any reptile. So I could say a snake or any amphibian, frog. Frog is an animal that breathes oxygen, but it's not a mammal, it's an amphibian. The inverse, we're going to negate, which means make opposite. We're going to make these two things opposite. So it's not going to change the order, so I'm still going to have the original order of my statement. So if an animal is a mammal, then it breathes oxygen. Now, I left some spaces in here because I want to make these statements opposite of what they originally were. So my original if statement was if an animal is a mammal. To make it the opposite, I want to say if an animal is not a mammal, then it doesn't breathe oxygen. This is the inverse. So make sure if you're doing these all at once, make sure you go back to the original statement each time. I don't want to take my converse and make it opposite. I want to go back to my original statement and make that negated. The final one is actually a composition of the first two that we talked about. I'm going to inverse and converse my original statement to get what's called the contrapositive. So that would mean I'm going to switch the order like I did in the converse, but I'm also going to put these nots in there. So if an animal does not breathe oxygen, then it is not a mammal. Okay, so we haven't talked about the truth of the inverse yet. So the inverse says if an animal is not a mammal. So can I think of an animal that's not a mammal that does breathe oxygen? Because remember, I want to meet my if part. I want to meet my hypothesis. But I want the conclusion to be the opposite of what it says here. So if I can think of an animal that is not a mammal but does breathe oxygen, that would prove this statement is false. And it would be the same kind of a counterexample that I had for the converse. Okay, so a bird. A bird's not a mammal, but it does breathe oxygen. So this can't be a true statement because it's implying that all animals that are not mammals don't breathe oxygen. The contrapositive, let's look at this one. If an animal does not breathe oxygen, then it is not a mammal. So a counterexample would be something that does breathe oxygen and is a mammal. Well, there's none of those, right? Because if an animal does not breathe oxygen, okay, so I need something that doesn't breathe oxygen that is a mammal. Well, all mammals are going to breathe oxygen, right? I can't think of any animals that don't breathe oxygen that would be a mammal. The things that don't breathe oxygen would be, microscopic organisms, and those are not mammals. Or an alien, an alien does not breathe oxygen, maybe, I don't know. But we don't classify aliens as mammals, they'd be their own species. See, contrapositive is true, because I can't think of a counterexample. And in fact, anytime you have a true conditional statement, so the statement you start out with was true, your contrapositive is also going to be true. The converse and inverse might be true, they might be false, so that's really a term-by-term basis. But if your conditional statement's true, your contrapositive will always also be true. So here's just another example for you to look over. Here's more of a mathematical example. If x equals 2, then x is even. Converse, I'm going to switch my if and then part. So if x is even, then x equals 2. Inverse, I'm going to negate it. So if x does not equal 2, then it is not even. And the contrapositive, I do both. If x is not even, then it is not equal to. Okay, this is a true statement. Here, converse is false, because I can think of another even number that would not equal 2. So 8 would be a counterexample here. So this is false. So if x is not 2, so if I think of any number that's not 2, but is even, okay, 4 is not 2, but it is even, so this is false. Contrapositive, if x is not even, so if I can think of a number that's not even, is it ever going to be 2? No. Okay, so these counterexamples, they have to be true for the if part and false for the then part. Okay, so I can't think of one here because any number that's not even, so 3 is not even. Okay, it doesn't equal 2, so that's true for both of these. Okay, 5 is not even, but it also doesn't equal 2, so this is holding up. Okay, because any number I'm thinking of that's not even is also not 2. So this is true. Here's one for you guys to try. So, give it a pause. Write out the converse, inverse, and contrapositive using this statement. And then I'll go through and I'll have the answers up when you hit play again, I'll be writing them up. Converse, I'm going to switch my then is going to come over and take place with my if part. Okay, they're going to switch spots. Okay, so there's my converse. My inverse, I'm going to put the words not in there. Most of the time it's just that simple. You put the word not in there. And the contrapositive, I'm going to do both of these things. So I'm going to put the knots in and switch them around. And that wraps up conditional statements and their other forms.